So here are a couple of examples of simplifying trigonometric expressions using the power reducing formulas. This first expression is just 20 sine sine x to the fourth power. Okay, so um, we have this formula from our formula sheet that we could rewrite sine squared a as 1 minus cosine 2a all over 2. And so, of course, we don't have sine squared. We've got sine to the fourth. However, I could rewrite sine to the fourth as sine squared x squared. Okay, that is to the fourth power. And that allows me to replace sine squared x with 1 minus cosine 2x over 2. We still need to square it. Okay, that's my first step. Well, I guess my second step. And then I'm going to actually square this just like I would any binomial. And so we've got 20 times 1 minus 2 cosine 2x plus cosine squared 2x all over 4. Okay, and this is just, this is a minus b squared, right? A minus b squared would give us a squared minus 2ab plus b squared. All right. And so I still have a second degree cosine here. I need to work with that. But for now, I think I'll just simplify 20 and the 4 in our denominator. That's just going to give me a 5 up front. And now I'm going to replace cosine 2x with 1 plus cosine 2x over 2. Okay, very similar formula. One of them has minus, the other has plus. Now, here's the catch where you need to be careful. This is 2x, right? So, you know, where they have a, we already have 2x. So if I double that, that's going to be 4x, right? So when I replace this, I get 1 minus 2 cosine 2x plus 1 plus cosine 4x over 2. Again, using the formula, they had an argument of a, and then they doubled that. Our argument is 2x. When I double it, it's going to be 4x. And so, you know, now we just need to kind of clean all of this up. I've split up my rational expression here. 1 over 2 plus 1/2 cosine 4x. Okay. And I'm going to combine my constants. That's going to give me 3/2, 1 plus 1.5. And then we got minus 2 cosine 2x plus 1/2 cosine 4x all times 5. And of course, if we multiply through by 5, this is the final answer that we get. All right, the second problem boils down basically the same way. A couple of ways you could have approached this. You know, one thing is good to note in the back of your head about the double angle formula, or I'm sorry, the power reducing formulas, that they both come down to cosine. Also, it's good to note that they are conjugate. 1 minus cosine 2a, 1 plus cosine 2a. So if we needed to multiply them together, it would probably wash out pretty neatly, which I think is what I'm going to do here. I thought about a couple of other things. I mean, you could have taken sine squared and rewritten it as 1 minus cosine squared. And then, of course, multiply everything else through and approach it that way. But as I mentioned before, I've just used the expressions for sine squared and cosine squared in our power reducing formulas and plug those values in. So I'm going to multiply through. Again, this is a minus b times a plus b. And so we get a squared minus b squared. So 136 times 1 minus cosine squared 2x. And of course, on the bottom, we just get 4. I still have second degree term here, trig term here. So I'm going to use the function again for cosine. Notice again that our argument is 2x, right? Right here where they have a, we have 2x. So when I use this formula, I've got to do 2 times a, or 2 times 2x. And so I get 1 minus 1 plus cosine 4x over 2, just applying the formula. And then, a couple of things we could have done, but I could have multiplied top and bottom by 2 to get rid of this complex fraction. But instead, I decided to go ahead and reduce the 136 over 4. That kind of reduces the fraction for us as well. And so we get 34 times what we have here in our numerator, 1 minus 1 plus cosine 4x over 2. Then I just need to finish simplifying this. It's 34 minus 17. 17 because 34 divided by 2 is 17 times 1 plus cosine 4x. I need to distribute this minus 17. When I do, I end up with 17 minus 17 cosine 4x.